Yeah, defense against diseases. That is 10.2 Igcse. It can be any other program that you do, but it's 10.2, where we talk about the defense against diseases. In the previous video, we saw what we called, um, we saw the first line of defense. We talked about diseases and the methods of spread of diseases. So today we're yet again looking at what we call the other lines of defense and how it works. So in this business, we expect you to discuss more about what we call we are going to discuss more about the cell mediated defense. We are also going to discuss about the antibodies production and all that stuff. So let's look at it and see. So the outcomes here, we explained that each pathogen has antigens, each with their own specific shape, which shape now promotes the production of antibodies in the body from the lymphocytes. We also have what we call the I explained the antibodies have specific shapes that are complementary to the shape of antigens. I also describe how antibodies destroy pathogens. We shall also define what an active immunity is. Then, as we go, so what exactly did we talk about? So, previously we talked about the first line of defense, which is made up of barriers. We have the chemicals and then the natural barriers. Where the chemicals the we discussed mostly the mucus, the sebum, and also hydrochloric acid, which happen to trap and kill some of the non-specific pathogens, which happen to invade the body from outside into the inside. However, we also have some other fluids like in areas where the immunity is so low, especially in some other openings of the body. Then we also discussed the lines of defense, the mechanical defense, where I talked about the hair, we talked about the skin. So now, if we are to go more into the second line of defense, here we define and discuss more what we call the cell-mediated defense. Cell-mediated defense, basically, we are talking about the defense of the body that involves cells. For example, phagocytes in the blood may engulf and kill any pathogens that manage to get through both the mechanical and the chemical defenses. However, as briefly described or mentioned earlier in blood defenses, these phagocytes need help to find and engulf the pathogens. So much as they are available to attack and destroy any pathogen, our phagocytes need to be helped. We need to identify which type of an enemy is invading the body. We also need to identify what exactly are we supposed to attack, how do we attack it. So in that body, all pathogens have chemicals on their surfaces called antigens. So every pathogen on its body, it has specifically designed proteins. The specifically designed proteins are referred to as antigens. So antigens are different. They differ in shape and structure, and when they enter into the body has what we call the lymphocytes. Lymphocytes are types of stem cells that are responsible for producing a certain specific kind of defenders, which we call antibodies. So every time a specific antigen is introduced into the body identifies the antigen, and that stimulates the stem cells in our body to produce specific defenders, identifiers called antibodies, whose role is to identify, attack, and present these antigens or these pathogens to specific phagocytes that will attack and destroy. So everything in the body requires an identification, or they have what we call the specific proteins which are supposed to be identified. Upon identification, we can produce a specific defender that can easily attack on that pathogen. For example, when we talk about blood groups, this is out of we talk about blood group ABO system. We appear to know that blood group A has antigen A. Whenever that antigen A is found on the surfaces of the red blood cells. So the type of proteins in blood group A appears to be like having a star-like structure. That's what we call antigen A. So this antigen A, the moment you produce it in the body, that blood will be rejected provided it is produced in blood which is opposite of A. For example, once antigen A is introduced on blood group A, that is on surfaces of red blood cells, it will stimulate the stem cells, which we call the lymphocytes, B lymphocytes, to produce specific defenders called antibodies of structure complementary to that of antigen A, which we call antibody A. So antibody A will go and attack on and attach itself on the star-like structure of antigen A and results into what we call agglutination. Agglutination is when blood coagulates as a result of the attack of antibodies that causes the blood to become solidified and clots within blood vessels, and that results into death. Blood group B has antigen B, which is in form of the three rotating around the circle, 3, 3, 3, 3. So that structure is called antigen B. So antigen B, once you introduce it in a certain blood, it will stimulate that blood to produce antibodies of that structure, which is complementary and can easily attack and result into that agglutination. That's why it is safe for blood group A to stay in blood which has antibody B. Antibody B is not complementary to antigen A. So they will not have agglutination, and we shall have a safe blood transfusion. We will do more of that as we continue. So all pathogens have chemicals on their surface called antigens, many of which are made of proteins. When one catches a disease, their lymphocytes, these are the type of white blood cells I mentioned, that come from stem cells, and they differentiate into two in a previous video. We said some of them differentiate and grow from bone marrows, others grow and differentiate from the thymus gland, which is found above the chest. So the ones which grow from the bone marrows are referred to as B lymphocytes. And those B lymphocytes are the ones responsible for producing antibodies and memory cells. So antibodies are as a response. So antibodies lock onto antigens on the surface of the pathogens, which will then engulf and destroy them. So antibodies are produced by the B lymphocytes, and so those cells are known as plasma cells. Their role is to defend, to attack the pathogen and make it weak, as we are yet to see how antibodies attack pathogens. How do antibodies attack pathogens? This is the first way. They cause the bacteria to stick together. Some of them bring these bacteria together, forming groups, which makes it much easier for the phagocytes. Remember, phagocytes, they are another different type of white blood cells whose role is to come and feed. They come and engulf those pathogens wherever they are located. So they cause bacteria to stick together. That is, if they are there, antibodies come and get these bacteria as pathogens, put them together, put them in a group, and this enables the pathogen, the phagocytes to come and engulf them at the same time. So the first way is putting them together to make it easy for the pathogen, for the phagocytes to come and feed on them. Number two, how do they do it? Number two is some bacteria have flagella. Remember, flagella is like the tail part of the bacteria, which it uses to fight and move. So some of these antibodies will come, come and attack the flagella which are used to move them, so transport them through the body. So antibodies can attach themselves to the flagella, which will prevent them from moving around the body, again making it much easier for the phagocytes to locate and destroy them. Number three, some bacteria such as those that cause tetanus and diphtheria release poisonous substances of toxins into blood. Some bacteria such as those that cause tetanus and diphtheria release poisonous substances of toxins into blood. A special group of antibodies called antitoxins. So these antitoxins here come from the T lymphocytes, which grow in the thymus gland. Antitoxins, which combine with these toxins, neutralize them, making them harmless. Sometimes people suffer from allergies, which happen as specific responses to a certain chemical. So some of these pathogens tend to produce poisons. These poisons, once they are produced in the pathogen by the pathogen, they can cause harm. So some of these antibodies produced will produce antitoxins. They will produce a chemical that will neutralize the toxins which the pathogens had produced to make you sick. So by neutralizing them, that makes them harmless to you. Then some antibodies are able to directly destroy bacteria by punching holes through their cell walls. Yes, most of these antibodies have stinging abilities. They will come and sting that pathogen and create walls, which walls will now later absorb water and cause this pathogen to burst open. And that way, the body is defending you. You are getting defended against these diseases, against these infections. Okay, against these infections. Now, some antibodies are able directly to kill. So, each type of pathogen has its own antigens with space or shapes, structures specific to them. The antibodies made against these different antigens have a shape that fits around the antigen, meaning that antibodies has a complementary shape to its antigen, quite like what we see in enzymes and substrate. Yes, so when you look at this, we are looking at how the lymphocytes, B lymphocytes have stem cells that produce particular antibodies which have a complementary shape to antigens on a pathogen and are produced to enhance the immune response. So as this comes, antibodies are produced which will attack on its function sites and cause this antigen from functioning. So the antibodies is specific to its antigen. Each lymphocyte only produces one type of antibody. So you have the T lymphocytes. This is lymphocyte B and 3. Then antibodies enhance the activity of a phagocyte by producing that one. You see many of them are attaching on this antigen. So they are putting them together for this phagocyte to come and feed on all of them or digest all of them at once. Immunity. What is immunity? When you have an infection, for example, the common cold, you feel ill and you experience various symptoms. But within a week or two, you will be feeling like you're normal. Health self, if the strain of the virus that caused the illness invades again, you won't get the same symptoms. So lymphocytes are responsible for this and are activated during an immunoresponse. What is the immunoresponse? We are born with a large number of different lymphocytes, which, like we have explained previously, and are specific to different antigens on the surfaces of the pathogens and bacteria. When a pathogen invades the body, the lymphocytes respond and divide the specific cells to make more of the type of needed to fight the pathogen. These lymphocytes grow, become bigger, and fill many ribosomes that are attached to a very extensive network of endoplasmic reticulum. The uh, antibody molecules are secreted into bloodstream and lymph and are distributed throughout the body. These antibodies then lock onto their specific antigens on the pathogens that have invaded the body. So what happens with what we call immune response? The first time you get a disease, it will treat you like when it's the first time you suffer from it, it will treat you so bad and you become ill. But in that process, your body is trying, first of all, to identify the type of antigen on that pathogen, produce antibodies which are specific to that antigen, and also produce memory cells. I repeat, the moment you get a disease, the first time this disease will cause you to become so ill. Reason being that your body has not yet produced any antibody that can fight such a particular disease. So what happens in that process as you're becoming ill, your lymphocytes are trying to learn the type of bacteria or pathogen that has attacked, copying the specific type of antigen on that pathogen, and trying to produce antibodies. So the lymphocytes will produce antibodies, but in the process, they will also produce what we call memory cells. So memory cells are going to remain there as a reference, so that the second time the same disease comes to attack you, you can feel it for like a few days, but again it won't make you ill like as it was before. What is happening? The moment this thing attacks you again, your body already produced what we call the memory cells. These memory cells will divide so fast and produce antibodies. These antibodies will fight this thing as quickly as possible, which we call the immune response. Immune response comes as a result of you are suffering from the disease for the first time. Your body lymphocytes produce what we call the plasma cells, which are antibodies that are going to fight that disease right away. Then also keep what we call the memory cells. These memory cells, the second time you suffer from a disease, the body will produce these, the memory cells will produce antibodies right away and fight the disease. You heal from it without even knowing you were falling sick. So that's what we call the immune response. So other lymphocytes, when activated, control the body looking for infected cells. Once they locate the infected cells, they destroy it in order to stop it from producing more pathogens. The reasons some diseases such as HIV are so deadly is that they are able to destroy the lymphocytes responsible for much of the defense in the body. So most of the pathogens we can form antibodies and also produce what we call memory cells that every time we can suffer from it, we can heal. But some of them are hard to treat. For example, HIV. Number one, every time HIV keeps on mutating, changing its structure, the antibodies that were produced yesterday cannot work on the one that is produced today. So it keeps on changing the structure. Number two, the antibodies, they are also having issues. I mean, it attacks the same antibodies that are supposed to identify it. That's how dangerous this thing is. It attacks the cells that are supposed to identify it. So that's how it becomes difficult. So, body's response to the first infection is very slow. This is now explaining what I've explained already. The body's response to the first infection is very slow. This is why many people suffer, fall ill the first time they are infected with something. However, by the second infection, the body is familiar with the pathogen, so the response is much faster. So fast you may not even feel any symptoms. This process of defense is called active immunity. Active immunity can be gained after infection, that is the natural way, or through a vaccination. So this gives us the other aspect of immunity called active immunity, whereby you suffer from a disease. When you suffer from a disease, the body is able to produce antibodies to fight against that disease and also produce the memory cells. So the next time you get this disease, already memory cells are there. This is what we call active immunity. And how does it come? Number two, it comes as a result of injection. When you suffer from a disease, they will produce for you the disease, okay, for the first time. Uh, Sometimes they prevent us from suffering from diseases by immunizing. Immunity or immunization involves either injecting you a halfway killed pathogen of that disease or a fully killed pathogen of that disease into your body, or injecting you that real pathogen but it changed it to harmless into your body to enhance your body to produce antibodies and also produce memory cells so that the time the real one comes, your body already has the immunity, has the capacity to fight it before. You've seen people taking astrocazena and then Pfizer as the immune as an immune as a way of immunizing. So what they are injecting in us is either a dead coronavirus or an attenuated virus. Attenuated virus is one whose effects are changed to harmless, but it's alive. They turn it to harmless and then they inject it into your body so that by the time you develop the disease, the real one comes, your body has all the antibodies and also produce the memory cells which remain in your blood so that every time the other one comes, they will be able to be copped and produce antibodies to defend your body against this infection. So when you talk about memory cells, what happens? During immune response, as we explained, many specific lymphocytes are produced, many of which develop into antibody producing cells. However, some do not. The remaining cells are called memory cells, and they remain in the blood and lymphatic system, saturate throughout the body until another infection where they will be able to respond much more quickly and efficiently than in the initial infection each time an immune response occurs. So I want us to see if I can play this small video from my friend.
Pathogens are foreign infectious microbes that cause sickness and diseases. The job of our immune system is to fight pathogens. cells are able to recognize foreign pathogens by their surface molecules. The immune system constantly scans the body for foreign molecules. If foreign molecules are recognized, the immune system will launch an attack. Foreign molecules that trigger an immune response are called antigens. The surface of a pathogen is covered in foreign antigens. Antigens have very specific shapes, and different types of pathogens have different antigens on their surface. When the immune system detects antigens, white blood cells respond by producing antibodies. Antibodies are special Y-shaped proteins that are made with a specific shape to match the antigen detected. Antibodies are marking flags that latch onto antigens just like a lock-in key. Pathogens that have been flagged by antibodies are then destroyed by special white blood cells. The antibodies you produce to flag one type of pathogen would not be effective against another. For example, the antibodies that flag the measles virus would not be able to flag the chickenpox virus. This is because antibodies and antigens work like a lock-in key. The shapes must match. As you fight different viruses throughout your lifetime, you develop the ability to produce different types of antibodies. This is how you gain immunity against certain pathogens. This is also what vaccines do. They trigger your white blood cells to produce antibodies so that you become immune to a particular pathogen. Now you might be wondering, why do I get a cold virus every year if my immune system has already produced antibodies? Or I've gotten the flu shot, so why did I still get the flu? Well, some viruses, like the ones that cause the common cold and the flu, have many different strains. These
So
viruses
the different strains that attack us every day, that's why we happen to get
antigens change
almost the
to
same
produce different
as
antibodies.
symptoms of a certain disease like common cold.
The flu shot will help you
So
to
different
detect
shots are
antibodies.
supposed to be taken, sometimes which we may not take all of them
There's always the
due
chance
to
that different
differences that
strains will
happen.
affect you.
So as you've seen, most of the different, this is a simple animation that was showing the different pathogens are having different proteins on their structures. For example, the ones you see, these are structures, and these structures are the ones which are what we call the antigens. So when this strain enters into your body will first of all take a cover, look at the structures on the functional parts of this pathogen, and produces antibodies that are specific, like the lock fits in a specific key on that pathogen, and that's how it can fight it. So antibodies of a given pathogen may not affect the other just because they have different structures. So they are specific in action. That is cell mediated immunity, and that is a very good discussion about that specific immunity as we had said earlier on. So let's check and see. Uh, okay. So if you look at this picture, it shows you measles virus particles inhaled. When you inhale, what happens? The virus particles spread throughout the body. So when they spread throughout the body, antigens on the virus particles bind to receptors of a specific lymphocyte. These are the B lymphocytes. Then B lymphocytes take it and start to study it. Then the B lymphocytes are activated and divided to produce what we call the active lymphocytes, which secrete antibodies, and those antibody plasma cells, and also differentiate antibodies bind to various viruses, particles throughout the body, and then antibodies help the person to recover. But in the same sense as we form the lymphocytes, we shall also form what we call the memory cells, which will be in position to assist us to help us recover from these diseases and these infections. So that's how these antibodies work. Then vaccination. What we call a vaccination, as I explained earlier, that after the initial infection, the body works to provide immunity. However, it is possible to promote active immunity without even having to be ill. This is done by injecting a vaccine that contains a live pathogen, dead pathogen, or antigens that are taken from the surfaces of a pathogen, or what we call attenuated virus. Each vaccine stimulates immunity to a specific disease, such as measles or mumps. The vaccine provides protection against a specific strain of that disease, as is the case with influenza vaccines. Vaccination is an artificial way to gain active immunity. So, with vaccination, is when someone injects you with either halfway dead, neutralized, or attenuated virus into your body with the aim of stimulating your body to produce antibodies and memory cells, and that is one way of helping you to acquire what we call active immunity. Active immunity. So the key points in our discussion today have been antibodies lock onto antigens, leading to the destruction of pathogens. Each pathogen has its own antigens, which have specific shapes, which fit the shapes of specific antibodies. Active immunity is a defense against a pathogen by antibody production in the body. Memory cells remain in the blood and lymph after an immune response to produce much more faster and greater response to subsequent infections. Active immunity is gained after infection by pathogens or vaccination. Then we can also discuss and say that explain what is meant by antigen, antibody, and toxin, active immunity, and memory cells. Outline how someone becomes naturally immune to a transmissible disease. Explain why vaccination is of active immunity. Define active immunity. So the answers are, you need to give me the answers, or you can type them. You can take some time and read about them. If you think you like this, you can still go subscribe and then you do more of our videos.